Hello.
How's it going?
Welcome back.
Okay.
How's everyone today?
Good.
Pretty good? Still cold?
Yeah, it's chilly here still. Let's go here. So, I don't know if we really have any intro things to say. Hey, Morgan. I don't know if there's any particular updates people want to share from last time. My only updates are I found a couple. I stumbled across a few Michael Levin things that I put in the Slack, and we don't have to go through them. I just
add the I mean, if to the Levin stuff, the that Earl Miller tweet that is. Sorry, I've got the I've got the paper here somewhere. But it's talking about frog brain development being shaped by basal bioelectric. Sorry, I'll find this.
All right. Oh, I think I know what you're talking about, but I don't know what the citation is.
Yeah.
I think I've watched this lecture. This bioelectric networks underlie the intelligence of the body. I'm pretty sure I've watched this one.
Okay.
I think we might have talked about it before. This one, yeah.
Yeah, that one. Okay.
But I just happened to go actually watch it through this time. But yeah, I don't have any other additional things to say outside of that. I do want to hold a space. We don't have to get into this now, but I know there was some talk about sort of project admin stuff, administration related stuff for this group, and I don't know if we want to. I think I'm kind of deep in the paper right now, so I don't really want to disrupt the flow of going through this thing. We just finished this big table. But maybe, I don't know, something to think about for next time might be thinking a bit more about like goals or structure for this group or the project in general. I don't know. I'm defer to Amanda and Bradley about that.
Yeah, we can talk about that another time, I guess.
Yeah.
Yeah, I did make a Notion sub for that. I think it has the phrase mission statement in it. Yeah, I don't necessarily want to do that today, but I think that could be good.
Okay. I see the link that Morgan shared. Okay. Let's start listening here. So I guess we'll dive back into where we were. I've transferred most of the notes for this one into this page. So basically everything we had last time is here. We have this table with a sort of extended touch and a lot of toaster talk last time, you know. And then we kind of were kind of wrapping up the very end of this column. So let me adjust this a little bit. But if anybody wants to kind of review what we talked about last time as I finish this and kind of, I know Morgan wasn't really here for it. We really just went through the intro and got to most of the table, but if anybody has any particular phrases they want to share about that.
why don't we next go up? There's a bit in the previous page about their claims. So let's go up to that so we can have those. There are 3 claims that they make. This last paragraph on the left column there on 2.
Yeah, okay, here.
Yeah, starting there. Yeah, there. Okay. So here we make 3 basic claims. First, the notion of machine, often used to claim that living things are not machines, tends to refer to an outdated definition of the term, which simply no longer fits. Which I guess is somewhat true, but I mean, that's there's always a problem with the distinctions between something and not something, right? I mean, they're talking about adaptive smart machines or what have you, maybe like genetically engineered things or whatever. Thus, we have the opportunity and need to update the definition of machine based on insights. And then we get to the next column. Information engineering and life sciences towards an understanding of the space of possible machines. So that's where they talk about table 1. Okay. So we went through table 1. We challenge relevant communities to collaborate on a better, more profound definition that makes it clear which aspects fruitfully apply to biological research, which I don't know if it's, I don't know what that, I guess what they're maybe referring to is like all these debates about an artificial intelligence where you have these things that look lifelike and we don't know if they're something other than like what we typically think of as a machine, which is mechanical. They'll use that term later, but not but anyways, so to make that distinction clearer, let's see, it doesn't let the go carve nature at its joints in the way it seems obvious in the last century. So that's it's just a different world, I guess. Second, the progress in the science of machine behavior and in the bioengineering of tightly integrated hybrids breaks down the simple dualism of life versus machine. I mean, you could say that about life versus non-life too. I mean, it wouldn't put you in any better position, but instead we see a continuum of emergence, rational control, and agency that can be instantiated in a myriad of novel implementations. So that's what they're talking about there. Protoplasm versus silicon, or origin story of all versus design. I think that their view of living systems may be a little bit. People would probably disagree on what they view as living, or how they define living systems. We can go into that, but and then finally we stress an emerging breakdown not only of distinctions in terminology, but of disciplines. And that just has to do with interdisciplinary work and engineers jumping into biology and so on and so forth. So that's their 3 claims. So that's basically where they're coming from. So what do you think about that?
Yeah, I guess we can go through each of the claims or a little bit more. What do we think? So I guess the first one is basically machines are outdated. The concept of machine is outdated, but it's basically the table one. The table 1 is their point, as in this. They're challenging relevant communities on a be better on a So I guess it's sort of like the embodied intelligence conference people and those of them who have the opportunity to make certain things more interdisciplinary, perhaps, and update it. I mean, like, we have the phrase "carve at the joint," nature at the joints. I feel like we should make a specific stub. I'm going to do that right now, just because I feel like that's sort of a phrase that comes up in very. I don't know. What does the phrase "carve nature at the joint" mean mean to you? I guess because we've talked about it a few times, and I get it, but it's also sort of
It means like to carve nature at its joints would be to pick out categories that actually exist in nature. So maybe one example of not carving nature at its joints would be um, I can't think of a good example. Maybe depending on your
talking about,
views. What is that?
I was going to say, talking about dogs, you know, it'd be easy to look at dogs and say they're different species, for instance. I mean, just an example. But that they're, you know, more biology would give you the opinion that they're actually the same species but just different breeds, for instance. Would be one. Levin likes to use the it's like Adam naming the animals picture in his talks.
Yeah, that's a good simple example. I was about to mention something more complicated, which is like depending on your views in, well, I guess this isn't that controversial, that like psychiatric categories
Well, yeah.
are not picking out.
Just jumping in for the real stuff.
But so the ones that are like syndromes, you have a collection of symptoms, but the actual cause of that set of symptoms, like the underlying reality, could be very different. So those categories would not be carving nature at its joints.
And if we want to keep it, you know, particularly literal, I've watched a lecture recently on neuroanatomy, like neuroanatomy for surgery, for brain surgeons, and like how they, you know, when you're looking at these autopsies, like how they decide, like oh, this structure, like this needs a name. You know, it all looks like one very complicated thing, you know, and incredibly hard to figure out where are the right places to call things. And
yeah, definitely always the seminal challenge of any science is to have like a good classification system or a good, you know, putting things in bins model. And sometimes things change, and I guess they're arguing with technology such that we can't use the old bins anymore. I think they're way too optimistic about that opportunity, but you know, it's something you have to think about. A lot of like artificial life, the field of artificial life, which of course Josh Bongard is very aware of. That, you know, that is like a field where you're basically started by people simulating life on a computer or simulating cellular automata on a computer, and then saying, well, it looks like life. Well, what does that mean, look like life? And then you have to like make these judgments about like, you know, something that is doing something different than what you're usually expecting out of a computer. And then, you know, you're kind of making classifications, and sometimes, you know, you're making you know, good classification. Sometimes you don't carve nature very well at its joints, and that's really the challenge of artificial life, is figuring out what those real categories are, I guess. So it's not never really you know, as things kind of move across their boundaries, you know, there always is that challenge. Whereas things change over time, there's that challenge. As our understanding changes, which is maybe more relevant, things change as well.
I think there's a fair, like, I think to tie into not what we talked about earlier or mentioned very briefly today with Levin's other stuff, like in his TAME framework, technology, but it's like even this is sort of like he's trying to from this viewpoint of intelligence or like almost like capacity beyond teleology isn't like being able to being able to pursue goals differently in this sense. I forget exactly what he said at the moment about this, but not just specific, not just be philosophically classic teleology, but meaning it in the context that maybe these guys were trying to get at, but also like that this is not being bound. A lot of what he's trying to discuss in his terms of his framework was these aren't trying to make language or ways or framework how to talk about it that isn't just bound to these familiar categories, perhaps, and something that would transcend across them. So it kind of fits, the effort is in the same vein, I suppose. But as far as what to think about, as do I think about it? Like, yeah, I agree. There needs to be there requires there's a necessity for innovation in these spaces. I think it's a similar question. Actually, one thing I'll briefly mention here, like I think it's a similar question as in the condition fusion and other things too, but like it's the sense of we talked a lot of reductionism in the other group, and sort of one of our challenges is like what do we do with the data and the use of things we found from reductionist terms, and it's sort of like there's what do we do with these things that fit into old ways of talking about them that are useful? And, like, do we just throw them out? How do we link those big, I don't really know what to call paradigmatically contingent ways of talking about things that have language and artifacts built around them and models built around them, and to new things that have different structures? That's the challenge on many fronts. So I mean, I think number one's valid. I just think it's in a lot of ways I think that's sort of it's everything and it's nothing. It's the tip of the spear and it's the challenge, and it's also at least what I'm saying about it. I'm not saying that's what the going hard in the paint about machine itself is outdated. I'm kind of on the agnostic side of it right now. I think Bradley's more like there's not a a little more leaning against it's not going to be I don't know. I don't want to speak for you, but you were hesitant about it. So
I mean, I have a kind of a question about the whole thing about teleology and how that fits. I mean, a lot of biologists wouldn't agree that like teleology drives the history of life or is even relevant in talking about evolution. And in fact, maybe that's the problem, is that there are a lot of, like in the cybernetic sense, we talk about teleology. Can you apply that to like life instead of like, because the cyberneticists were talking more about technological systems. I don't know. I think that there's way too much emphasis on that in terms of like purpose in driving biological systems versus purpose in like a technological system. And I get to sort my thoughts out about that, but yeah. So I mean, what that means is you'll probably be seeing like some written work on that. So, but yeah.
yeah, go ahead.
Well, I was just going to say, yeah, I in general, whenever that word comes up, I run away.
Yeah.
Yeah. like no good conversation has been made better with the word teleology. But sorry, yeah.
Oh, well, I think it's very interesting. We go back to the cyberneticists and what they meant by certain terms and what that, because like feedback is pretty loaded too. Like people say feedback And like there's what the cyberneticists meant, or what control theorists know, they're what like neuroscientists will say, and then it'll be different. There was I'm going to talk about this Saturday, but there's a thing about feedback and some of the things it does in systems. And sometimes if you're a control theorist, it's pretty obvious. Sometimes if you're a neuroscientist, it's kind of like you don't think about it. And who knows what the cyberneticists meant originally? I don't know. Teleology may be the same thing. And we talked about that with Norbert Wiener. You know, he had ideas about things that were, some of them stood the test of time. Some of them were kind of ideas that were kind of colloquial. So I mean, I don't know. When you use words, sometimes they mean very different things, and sometimes when you go to different fields, so it's not just carving nature, it's joints, but like different communities start meaning certain things by a term, and it's different, and yeah.
Yeah, that's I don't know. I'm in a period of deep meditation and sort of agnosticism about that topic in terms of a particular macro sense of like inherently I'm kind of against theories for everything, and to that end I may also be against language for everything, and like one like it's this really tough division between because you know I'm stepping back out of this looped comment on like everything condition features yesterday. I'm looking. I just got the book. I just looked at the book for the first time that Morgan mentioned called Mind Fixers for the neuroscience and DSM one, and it's really good. At least because it covers a lot of papers, according to Jen's research or study on this. A lot of the papers talk mostly about like pre-DSM-4 stuff, and there's not a lot on the recent things. And so the person's giving a nice authoritative history about what's going on. And I find I just kind of I skimmed it and looked at the last like afterthoughts conclusion, the last 6 pages of the book, where there's a lot of what I would love to happen in the future, and it fits. It really fits a lot of the things we're talking about, and like there's this sort of I see. I'm both like really excited and really I think daunted is a fair word at you know everything around. I've been saying the word person studies or people studies or individual studies or whatever human experience studies, but like everything that touches that space. Um, there's all these very niche. It's so much of it is made esoteric by a lot of different reasons and out of necessity to some extent. But like, I would love for there to be a better, you know, cognitive science in a sense. But I think sort of the driving motivation for it in the old sense is, oh, finally we found this thing we can build all of our stuff around, and it's going to be computation and talk about it this way, and we're going to develop a common language that's going to help us with, and from anthropology to neuroscience, and back again, whatever, and it's like going to be through that, and it didn't really quite work out that way, and so I feel like whatever that is I'm in a stage of having a lot of it's not going to be solved. I don't think I'm going to write the equation or create the master language for it, but I feel like the what do we do about it is a very across the different domains too, and I'm slowly getting more experiences in the breadth of the domains and seeing what people and I'm being able to identify kind of the same um, you know uh, even just the language issue, um, no less language and models and then artifacts, but uh, it's definitely the I kind of go back to this one for like, okay, uh, there are reasons there's important and valid ways to talk about machines in that sense, and we kind of went through I don't know. We kind of went through we went to the most of the three columns in the table yesterday or last week, and there's things that fit and things that don't fit. So I guess I just will move on to the next point and kind of get back to the table.
Did Morgan want to finish his thought from before? Or?
Again, I feel bad just because I'm coming with a lot of Michael Levin, lectures in my head, but it's like I know that he's thinking about, you should be able to describe any kind of 3D creature you want,
Yeah.
and you should be able to construct that.
Right. Yeah, that's exactly what he was pointing at in that last book. I want to make this thing where you can put this and it'll reconstruct it.
Totally, right? And so in that regard, like we're not there yet.
Oh yeah.
But it is very clear, what he means by like the definition of machine has changed when you can think about designing any biological creature you want.
Right.
Just the anatomical compiler is what he called it.
Yes,
right, yeah.
Thank you. Yeah.
Which I think is it's a lofty aim for that thing to be there, and we're definitely not there. And I have a similar apprehension about the word theology, and even honestly, like I know I probably shouldn't feel this way, but even things like ontology and like all of those words kind of. I think ontology is a great word, but when it gets talking about it in certain ways, I don't know. I don't know what to do in some cases, but anyway, fair enough. I guess we could go to the second point of the three claims, which was progress in science and machine behavior in the bioengineering of tightly integrated hybrids between living things and machines breaks down the simplistic dualism of life versus machine. Instead, we see a continuum of emergence. I think I like this, and I don't know if I agree with the bounds, but I think there's a lot of work on. I think a lot of the work across many fields is, raw dichotomy, and then you have these outliers that are looked as weird cases. It can be from mental health to psychiatry to, especially around the person, the whole human stuff. I think is particularly not there isn't a great amount of nuance there. So on that angle, yes. On the lens of his specific bounds for this, I don't know. What do you all think? About,
yeah, I mean that's one thing about biology is it as opposed to like physics, or at least this is what people always say, is that biology has many more edge cases than physics, which I don't know. I mean, I guess I agree with it in the sense that, like, if you take a classification scheme, if you say, for example, ask what is a species, and they're like, probably 30 or 40 definitions of species, and just depending on like the different properties of different, taxa and how they are defined as a species. And so, if you try to use one overarching model, it gets harder to fit everything into it. And so there are many more edge cases or exceptions in biology than you see in physics, or, at least that's what people like to say. And the same holds true with machines or engineering. And so you have this, I guess there's this dichotomy there. And, when you merge the two, the dichotomy breaks down or the dichotomy changes. So it's, it doesn't maybe make sense to talk about the dichotomy anymore. On the other hand, science, they love dichotomies because, well, we know from Cartesian dualism that, people love dichotomies. So that's always a challenge. It just makes things easier a lot of the time, but then it doesn't always make things easier. So, those are my thoughts on it.
Yeah. And I feel like I feel like in my super lofty aspirational like science and technology history, philosophy of science studies, I feel like there's I know there's certain like I understand a little bit about including revolutions and sort of the pre-paradigmatic or whatever states and other ways of thinking about like paradigms and paradigm development and that's stuff. And there's a lot of there's debate about, is neuroscience, how pre-paradigmatic is this or that discipline being right now, et cetera. And I feel like I think there's a really wonderful language to be had about the inherently reduced simplistic things that had to happen first before more nuance could be added, and the struggle of that. I think that's something that in my sympathetic view of a lot of things, I think that's like a major key component for me is uh, the necessity of the inadequate descriptions and the lack of nuance, but also how do you guide past that? And it's tough. I don't know that there's really a way to do it. Others like that is part of it. So yeah. Any other comments before point 3?
Well, I guess one part of 2 that I was like pretty convinced by was that so one of the I think it's on this table. Yeah, so that machines arise from a design blueprint. That's in the old conception. Oh no, that's not the right line. Anyways, it's that the old conception of machines is that they have to be designed by an agent for a purpose. And Levin talks about how if you count like machine learning algorithms as machines, they can design further algorithms. So there's kind of like you can have machines that make more machines. So that conception of what differentiates a machine from a living thing, being that a machine has to be designed by a living thing, that I was pretty convinced that, yeah, that doesn't hold anymore. That definitely seems like one case where the boundaries have been blurred.
It's kind of an interesting thing about that a little bit in the sense of like, in the spirit of the every good regulator theorem, to like a living thing can make this must be able to account for this state space of the machine, and maybe that's not the case anymore. I don't think it's a solid match, but it kind of it's interesting to kind of consider I don't know how from a very specific perspective. Yes, in the past, a living thing would have to make a machine in this way, and the view. I don't really want to say hierarchical view of that, but the view why that makes sense and why it might be shifting now, in a sense of, in a great sort of utopian-ish sense. Oh, now we can co-evolve together and we can be non-hierarchical, and that'll be great. Sure, but also the sort of interfacing capacities. Like there was a line here, I can't remember what it was, but I'll go back to this one again. In this talk, Levin uses the word affordances in a very specific way regarding, I can't really even remember, but it was, I wish I could just pull it up and mention it here because I think it would be relevant to kind of what we're getting at. But yeah, I think it's an interesting point. And I think there's something to agential materials and what is it? It's interesting because there's sort of when this is sort of I am intending for there to be a shape I want there to be, but at the same time there's sort of this not coercive versus non-coercive intent, and whose purpose and where and what purpose, and how do you gel with the purpose of these biological machines and things with their own agendas. But yeah. Anyway, and the third point is we stress an emerging breakdown not only in distinction of terminology but of discipline, suggesting emerging aspects of different fields like information sciences, physics, biology, into a new field whose subject is embodied computation in a very wide range of evolved design and composite media at multiple scales. What do people think about that?
Yeah, so if you go to the paper, you have the page up, and if you go down to the bottom, the left-hand column, that bottom paragraph right there.
Yeah.
Yeah, moreover, starting moreover. Yeah, they talk about here how machines are becoming highly integrated with novel systems within living systems, or integrated novel systems with living systems. They talk about sensory augmentation, brain-machine interfaces, brain implants, etc. Performance augmentation. So this is all like, these are all things that are in. There's a term that people sometimes use for this. It's just, and it's actually an ecological term. It's symbiosis. So this is interesting because like they don't really mention symbiosis here, but and symbiosis is basically where you have two systems. Sometimes there are two organisms in ecology, but in this case, it's a machine and a living system that are working together, and they're both benefiting from their interactions. And so this is a term that goes back to Licklider and some of the stuff that he did in the 60s. It actually, that's human-computer interaction is where that was kind of brought into the technological sphere. And then, people have used the term throughout, like with respect to HCI. You don't see it as much with like BCIs and people talking about that, but but the idea is that it's symbiosis and it's a symbiotic relationship, but it's actually there's a machine involved, and so that's the thing that they're getting at here. But yeah, it's the idea is that they're going if they're interacting that heavily that they'll become intertwined and interdependent. So like the Borg in Star Trek are so interdependent on technology that they die if you take out their implants.
Well, there's a good biological example too. Just one of the people at Biopunk Society is working on like synthetic or artificial lichens. So which are symbiotic relationships. It is a symbiotic relationship, right? And then so that it's interesting because it does seem very Levin to imagine a synthetic lichen that you're kind of relying on the agency of these species. In the case of a lichen, it's I forget what there's a kind of class of bacteria that interact with another class. Sorry, again, I can't look it up right now, but interesting thought, and certainly something I was going to say earlier. Just like the way in which Levin relies on, it's funny just thinking about like my training in biology. There used to be this kind of like you're either a geneticist or you're a biochemist, and he's definitely got a third class here where you're kind of letting the agential matter, you're kind of learning from the agential matter in a new way. I mean, it's like it's almost animal behavior, but but molecularly, or like
yeah.
it's interesting.
Exactly. in that way, it's almost like a more pure biology than one that focuses on the chemistry of the genes.
Yeah, the reductionism. I forget the the geneticist, like I forget if it was the geneticist or the biochemist, but they had like a car analogy that they'd use about like, we try and figure it out this way and they try and figure it out that way. And yeah, we're definitely talking about another way here.
I think I really am glad that last like 2 minutes of discussion happened, because when you go to like when you go to his website and he talks about like these what he's doing and like information processing and biological structures, and there's another phrase that's somewhere in here that he talks about. Maybe it's even in the new directions. But like, I don't know. It was really helpful to have the discussion, because there is sort of this element of, it gets been hard. Like, I get it. Like, I kind of get like the cognition and the biology stuff, but I think the discussion we just had gave some nice context to that. So yeah. Any other comments on the third point, which is sort of we need a new field, embodied computation. We need a new synthesized field that brings some of this stuff together. I have a comment, but I'll say it last. I'll put on a specific hat to say it.
Okay.
Anything else? Okay. I'm going to put on my kind of annoying, polemic, not critical theorist, but like the critic, just annoying critic hat. Let's just say that, and I'll say yes. We totally need new fields and innovation in language and disciplines, because if we don't, we're not going to get where we need to go. Embodied computation, as it, I think, is the cool way to think about it. I don't know if that's it or not, but yes, we need new fields and new ways of thinking about it. We need to advance the language, advance the models, advance the artifacts, advance everything, because we got to do that. So to take that hat off and kind of not just say, I think, I don't know, obvious stuff. I think what's interesting about Levin is that I think he's kind of a little bit of someone who's in a unique space, and I think it's quite interesting that we're talking about him directly after Norbert, because I think Levin has his hands in enough stuff to see some of the things. I'm not beholden to the anatomical compiler, or some other things, but I think he's in the space where he can do some of these things that will provoke other people into having to deal with some of the changes being put forth here, and I think that's interesting.
So I have a word on the anatomical compiler, actually. So I mean, I guess if it's like something where you have, I guess we could say, a simple enough organism, you could do an anatomical compiler. But then there's this notion in biology of increasing complexity. So there's certain model organisms that are chosen as model organisms for a reason, because they're very simple. And you may think of like with the flatworm or C. elegans or some bacteria that are in the sense simple. So like the people at the Craig Venter Institute, they've developed a minimal organism with a minimal genome. It's a bacteria that you can boot up to do certain things. So you have this minimal genome, and then you put in genes to do some specific task. And we, in that sense, we can boot up an organism. We can compile an organism. Or like in the case of flatworms or C. elegans, we understand all the cells. We understand what the genes typically do. They're a lot. And then you're starting to get where we don't have a minimal genome. Well, we can still kind of predict some of the things that it can do. We can have defined mutants. We can, have regeneration or things like that. And then when you get maybe more complex, and we haven't I don't think people have really characterized this very well, but it's worth thinking about, that you get to a point where it's just too complex of a system to really be able to effectively engineer it or to control it in a meaningful way or to understand it. Now that we've run into this problem with OpenWorm because people have asked, like, when unfortunately one of the sort of the goal, one of the ways that people have viewed OpenWorm is that it's, creating the world's first digital, worm or organism, I guess, or, something that we can understand every aspect of it and turn it into bits and so forth. So, I mean, that's not even, I don't even think, a long-term goal of that project, or that you could even do that with C. elegans. And so the question is, if you have a very, very, very simple organism, you could maybe do that, but at some point, it just becomes overwhelming. And sometimes to model a system like that effectively, you don't even need to really model every aspect of it. It's just modeling certain aspects, building an abstraction that works. And so that, I mean, that's a sort of separate and apart from this paper, but it's worth thinking about with respect to like living systems and machines and, that sort of thing.
I think the last thing I'll say about kind of that and kind of point 3 and we're almost out of time again. We barely even got down at the table, but it's still good. I think the last thing I'll say at a high level is I do really like that Levin. I think to draw upon the Norbert Wiener analogy a little bit more, I think Levin is at a unique vantage point to see, and I'm going to go back to his website because I always love to mention this specific thing. I think he's at a unique vantage point to see the need he describes here about towards a framework for understanding, relating, blah, 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 evolutionary biology, and expression about ethical and social frameworks that will become essential in the future as different forms of agents or arms diversify what's currently imaginable. I think, and I don't know, I would love to I don't know, I haven't really seen, I know he talks about this in something, I haven't seen it yet. But like, I think there's a little sense of, I'm not saying he's well, this is a painful analogy. I'm not saying he's trying to open AI and release a framework ahead of time so the general public can get aware of things, or whatever, however you want to interpret OpenAI's original mission statement about releasing GPT into the world. I don't think he's doing quite that thing, but I think there's a similar element of, I think he's trying to a little bit get ahead of the curve. And I think to an extent, I give a little tip of the hat to that. And I think it's not the same as, 10 years from now, we're going to have AGI and then anatomical compiler, and that's going to be a reality. No, but I think I respect the attempt at foresight, even if it's potentially misguided in certain fronts. But I don't know. That's anything we spend pretty much the entire time on the three points, which I think is valid for the group in general in a lot of ways, outside of this paper. But I don't know. We were kind of around here on the last. We had like 3 left. I don't know if we want to try to talk about them at all right now, but the categories beforehand were properties of the classical machines that don't apply to life, current and future machines that are not distinguished from life because, and then proposed new emphasis, which I think now I might say proposed new emphasis in a potentially, what do they call it? In a potential, like proposed new emphasis in a potential new field of embodied computation maybe should be the title there.
Yeah.
Because I
I
think
think that's
it might help differentiate some of their stuff and even kind of break it down along these lines of the claims they were making. Um, uh, we kind of talked about Godel and Turing and chaos. I think um, achieving holistic certainty from uncertain parts, like, is that essentially? I guess that fits with the anatomical compiler a bit. Like, we want this holistically certain particular end game, at least one aspect of it, but we're working with sort of. For the anatomical compiler, is he implying that there's no like black box effect, that we know everything, or that we just know enough to get a result that we want?
I think
don't-
that, yeah, I think that's a little bit of, you got to think about this in terms of how do, say, like lower level components like genes contribute to the production of proteins, contribute to the production of tissues, like you see here. And that's a little bit of a tricky thing because, on the one hand, we know that, like, we know some things about like regeneration, as you see here. We know some things about development, but we're also talking about emergence, and this term, achieving holistic certainty from uncertain parts, is key because that means that your compiler, unlike a computer science compiler, uh, is really based on some level of uncertainty. And so when you think about like emergence, one of the issues with like emergence is that you have these interactions between parts, and they produce this thing that's greater than the sum of the parts at the next level. So you might have proteins and genes interacting, and they produce a tissue. And in some cases that might be an emergent process, which we can't fully describe these sort of the additive components or multiplicative components to get there. But we can get there maybe in a number of different ways just by having those things interact. And so, and the thing about like emergence is you famously can't reverse engineer emergence. So you can forward engineer emergence by saying, I can create the conditions for emergence and I'll get this result if I can take a number of pathways to the result and it becomes this emergent phenomenon. So if I have a bunch of birds interacting in a flock, I can get different patterns in the sky and I can see those patterns as this emergent phenomenon. But I can't necessarily reverse engineer that flock and say, this is exactly how the birds interacted to get there. There are a number of answers. So it's like, and that's the problem with like, a traditional compiler, you should be able to know exactly what the instructions executed were. And then if there's a problem with the compiler, you can like go back and debug the uncompiled code to see where you went wrong. With a biological system, with an emergent system, you can't necessarily do that. And then that's an issue that is, of course, a problem because, that's just going to exist in a lot of systems outside of like your very simple model systems.
Yeah. I mean, I can see how he could imagine, though, an anatomical compiler that's kind of using agential material.
Yeah.
And it knows how to, when to inject the right growth hormones and etc., such that you can get any macro anatomical structure,
Right.
Like you're saying, but still not knowing, not really knowing how it all works.
Yeah, you'd really have to. Yeah, you really have to have like heuristics in place. Like you'd have to say, we know that if you inject this factor at this time, that it'll go in this direction. But it would be a fundamentally different exercise than what we do now in engineering, basically.
Yeah, and I think that's where like I kind of like that. I guess in this sense, I like that the idea that I suggested ideas like embodied computation because I think that's a really interesting space. Like we have even like kind of awkwardly going back to my OpenAI commentary, the world's now like thrust upon this sort of generative, emergent-ish not even data, but like, here's an essay, here's 500 words on whatever. They're words, and you can just, click through them or whatever. But now it's sort of, getting that back towards. I brought this part up from the axolotl stuff, where it's there will the different um, it stops when the correct large scale set point target morphology has been reached, and there's certain there's a lot there. There's a lot there. I'll say, and I know I think we're kind of out of time. Pretty much. But yeah, I'll hold for any final thoughts. I think it was nice to kind of we went through the 3 points. We kind of went to the table and recontextualize the table a little bit, and I think that's a really interesting point in this proposed emphasis in this table. Maybe next time we can finish them off and get further in the paper. But any closing thoughts for today?
Well, so this point in the table, and then the last one, that machines can perform a desired task in increasingly diverse ways. That, I mean, Levin quotes, I think it's William James, that like intelligence is being able to reach the same.
Go right.
Yeah, so I feel like I have a pretty good understanding of those last points because I'm familiar with Levin's kind of take on this. Yeah, great. And then I guess up to logistics. I'm again happy to meet next week instead of waiting 2 weeks, and then maybe next time we spend a little bit of time working on like a kind of mission statement that will guide our paper choices. I don't think we need a whole thing like we did for cognition futures, but just a little bit of it.
Yeah, so that sounds good.
Yeah, definitely.
I'm up for that.
I don't know if he's got a new Anthrobot paper. I don't know why the video link that I dropped in the chat, the person, the host was just like, I held this back because they were, it held it back for some reason, and it seemed like it was related to a paper, but so I'd be interested to know if there's a newer Anthrobot paper. But anyway.
Okay.
I was thinking about computation and the Adam-Matsky stuff in terms of using organisms for computing, as well as kind of being a kind of, like Bradley was saying, like you don't really know what you're gonna see until you kind of let it play out, sort of like he did with the Xenobots, which kind of reminds me of sort of like Wolfram, like cellular automata stuff. Like this is the only way to compute this is to run it. But anyway, happy we're going through this stuff.
Okay. I guess that's it for today. So I'll see y'all next week, and I'm up for meeting Thursday, and what Amanda said. So I'll see you then. Thank you.
Yeah, see you then.
Take care.
Take care.